Investigation of curves, section 2, derivatives of curves. Video 2, tangents parallel to the axes. You're probably already very used to working out where the tangent is parallel to the x-axis. This is what we look for when we look for a stationary point and we look for dy by dx being equal to 0. To find where the tangent's parallel to the y-axis, what we do is we look for where f of x over g of x, which is dy by dx, has the property that g of x is equal to 0 and f of x is non-zero. So we're expressing the derivative in the form of a rational function, and the denominator in that rational function is 0, but this is very important, the numerator has to be non-zero. If they're both 0, something a little bit different is going on, and we're going to be looking at that in a later video. Let's have a look at an example then. Find the points where the curve with parametric equations x is 5 cos t minus cos 5t, y is 5 sin t plus sin 5t is parallel to the y-axis. So this is the set of parametric equations that we looked at in the last video, and we found the derivative. Now we're going to look at how to use that derivative to find where the curve is parallel to the y-axis. So this is what we did in GeoGebra last time. We worked out the derivative as cos t plus cos 5t over minus sin t plus sin 5t. What we need to do now then is we need to look at the numerator and the denominator there and find out when it's 0. So starting with the denominator, so I want to solve, and then I've got sine of 5t minus sine of t. I want to know when that's equal to 0. And it gives me that that happens when t is a half k1 pi and t is a third k2 pi plus a sixth pi. So it's expressed it with these constants k1 and k2 that can take any integer, and so to work out the different values I just substitute in k1 equals 0, 1, 2 and so on, and k2 equals 0, 1 and 2 and so on. So for this first bit here, I'm going to have that t is 0, it can be pi by 2, it can be pi, it can be 3 pi by 2 and so on, but I'm only interested in t up to 2 pi, so that's that. And then for the second batch, I've got when k2 is 0, I'm going to have pi by 6. When k2 is 1, I'm going to have a third of pi plus a sixth of pi. That's just going to be pi by 2, which I already had. Then I'm going to get 5 pi by 6 and 7 pi by 6. I'll get 9 pi by 6, which I've already got, and I'll get 11 pi by 6. So the next thing to do is to check when the numerator is 0, because if the numerator is 0, then I'm not going to be counting those solutions. So let's solve, and I've got cos of t plus cos of 5t, and I want to know when that is equal to 0. And you can see that this solution here, a third of k2 pi plus a sixth of pi, is the same as one of my solutions here. So this is immediately telling me that all of these solutions here, when this is 0, this is also 0. So I've got both the numerator and the denominator 0, so I'm not going to have the curve parallel to the y-axis there. And then for the second half, I've got a half k1 pi minus a quarter pi. Let's have a look at how we can start writing these solutions up then. So I know from the previous video that dy by dx was equal to cos t plus cos 5t divided by sin 5t minus sine of t. And I know that the curve is parallel to the y-axis when cos t plus cos 5t is non-zero and sine 5t minus sine t is equal to 0. So, sine 5t minus sine t equals 0 at t equals, and then I had 0, pi by 2, pi, and 3 pi by 2, and also pi by 6, 5 pi by 6, 7 pi by 6, and 11 pi by 6. But cos t plus cos of 5t equals 0 at all of these except 0 and pi. So at t equals 0, x equals 5 cos t, so that's 5 cos of 0, which is 1, minus cos of 5t, so that's 5 minus 1, which is 4, and y is 5 sine t, well, sine of 0 is 0, so I'm going to get y equals 0. And then at t equals pi, I've got x equals minus 4 and y equals 0 again. So I've got that the tangent is parallel to the y-axis at the points 4, 0 and minus 4, 0, which if you look on our graph here, you can see that at 4, 0 the curve's going vertical just there, and at minus 4, 0 the curve's going vertical again. In this video, you've learned how to find points where the tangent is parallel to the axes.